Hi, in this tutorial we will apply the rules that we were discussing previously for transforming ER diagrams into a set of relationships. For this we will use the following ER diagram as our example. Okay, so here if we inspect we can probably get the idea of the meaning of the specifications for this database. For example, we can see cities is an entity set that has two attributes, and then we got employees that have a relationship with city because the employee lives in the city. Then for employees, we got the employee number, which is the social security, and then you see that we also have hobbies, that is a multi-value attribute, and work on is a ternary, no, it's a binary relationship. It's a many-to-many relationship between employees and projects. And use is a ternary relationship that we have among projects, programmers, and languages. And programmers is also an employee. You see that we also have the years of experience as a programmer. Managers is also an employee, and managers they seem to uh, manage a budget because we got that information there. Then look that relationship work on has an attribute hours, and let's apply the rules. So what we need is a set of relationships. So then let's get a little text box here and let's work. Let's select. So then let's work with cities. So let's say cities is my first entity. Now, entities, we inspect the relationships in which the entity participates. Cities is only participating in relationship live in. Why we are checking that? Because we may get a foreign key from there. So it's participating in a relationship that is a one-to-many. And if we remember the rules, the entity that has the one doesn't get any foreign key, but it's going to be passing a key to the other entity in the M side. So then cities is my first table, and then I have C underscore name, and then comma population. Okay, and this is my first relationship, and I will underline C name because that's the foreign key. Okay, so we're done with cities. Okay, so we got only those two. So now let's move from there and see. Okay, we got cities. Now we got a relationship. Relationship may be tables, but this is a one-to-many. One-to-many do not become tables, so live in is not a table. Now employees participates in two relationships, so we may get foreign keys for those two relationships. So live in, we're getting a foreign key from cities. Work on is a many-to-many, so we don't get a foreign key. Now employees has also hobbies, which is a multi-value attribute. Then once we know that information, then we can say employees is my other table. Then employees is going to have employee number, name, and age. Now we're getting a foreign key, which is city name. We got that because employees is participated in one-to-many and it's in the many side. Now we have hobbies. So hobbies is a multi-value, so we know we have to create an additional table. Okay, so then it will be employees hobbies. So we say somehow we get the we create a new table and we usually combine the name of the two table of the table and the attribute, and then if we follow the rule, it's gonna be the employee number together with one of the hobbies, the one that will be the key. So this is the primary key and this is the primary key, so we will underline And then in employees, I think I forgot to underline this as the key. So far I got these three tables. Now let's move. Let's see, now we got managers and programmers, which is my other entities here. Now managers is not participating in any relationships, so managers is not getting any foreign keys. So then we say managers. We get the key from the employees, so this is employee number. Remember that we're applying the rules of is a hierarchy and then budget. So then we underline this. Now the other entity that we have, that is programmers. Programmers is only participating with a ternary. From a ternary relationship we don't get any keys. So then let's go into programmers. Now programmers, we get employee number and then years of experience. And employee number is the key for this, and it's also foreign key in this case. Okay, now if we inspect, we haven't done anything with projects and works on. Okay, so projects is participating in two relationships. One is a many to many and the other is a ternary, so we don't get any foreign keys there. Okay, so then let's do that. So we got projects. So we got project number, name, and that's it. No foreign keys here. So we underline there. Then work on is a binary relationship, but it's a many to many, so that's one of the cases in which it becomes a table. So then work on, it is a table, and it gets the key from the two participating relationships, from projects and from employees. So we get an employee number, comma, project number, and we got an attribute hours. Now employee number and project number together will be the primary key. Now we got use. Use is a ternary relationship, so let's move this. So we need to be sure that we get all the entities, relationship, and attributes. I mean, we consider all of them doing this. So the next one is use. So remember, relationships that are ternary relationships are also tables, so we get the key from each of the participating entities. Programmers, which is the employee number, the key. From the key from languages, which is L name, language name, L underscore name, and set underscore, right? And projects, which is project number, and use doesn't have any other attributes, so we close that, and these three together are the primary key. Finally, languages. Oops, shouldn't be underlined. So languages, we only got one attribute, so that doesn't really make a lot of sense. Language name. Maybe we can add something else like a version or something like that. So this is the answer. This, what we have in the text box, is the transformation, the resulting relationships that we derive from that diagram. Thank you.